Hi AP Stat, it's Miss Meadows, and we are going to take some notes while you listen to me talk to you. You should have this worksheet titled the kind of best fit regression line. And if you want to go ahead and write down this definition. So I'm hoping that most of this is review. You've seen the best fit before in one of your algebra classes. You already know linear equations like y equals mx plus b. So I'm hoping it will be fairly reasonable. You also had a homework assignment on the rat problem that you had on the weight of a rat over time, and that also had you practicing interpreting slope and y-intercept and making predictions. So hopefully this should go very painlessly. But we're going to go back to our beer and blood alcohol content data. So it should already be entered into L1 and L2 of your list. And I just want to show you how later does the line of best fit in just a minute. But I've already made the scatter plot over here. So if you press zoom 9, you should see the exact same scatter plot on your calculator screen as you see up on your. And I got the correlation for you too from last class of 0.894. So the whole point here of a line of best fit is to say a little bit more specifically what the relationship is between your x variable and your y variable. And ultimately it's used to make predictions. We want to be able to plug in an x value and give a reasonable prediction for what the y value should be. What I want you to do to start, and I'm not going to have the sub hand out rulers, so you can just use like the edge of your calculator. I want you to just kind of eyeball what you think would be the best line, kind of represent the trend that's happening here with the scatter plot. So there's mine. Hopefully while you were doing this, you were trying to kind of balance how many points were above the line and try to be as close to the points as you can, but not necessarily going through any number of points. If you go through some, that's great, but it doesn't have to go through any of the points. How do we actually make sure that we have the best line? Well, that's where we're going to get our calculator to help us. So since our data is in L1 and L2, you can do the same calculator function directions we had last class for correlation. You're going to go to Step, over to Calc, and go down to number 8, please, linreg a plus bx. Make sure your x list is L1, press second 1 if it's not, and your y list is L2, 2, blank for the next two things, and calculate. And now, in addition to our value that's at the bottom, we're going to also now talk about the a and the b value here. You see the equation says y equals a plus bx. The a value is that's our y-intercept, like I wrote over here on the paper. And the b value is next to the x, so that's actually your slope. I know that's a little tricky because you're used to b, like y equals mx plus b is usually the y-intercept, but we're going to leave it like this, and I'll show you why in just a second. So we're going to take our calculator and record our y-intercept. We want to give at least 2 sig figs, and be careful with your zeros, your decimals, your negatives, and then our y-intercept. I'm sorry. The y-intercept. This is our slope. Just said that. The 0.018 is the slope, and this negative 0.013 is our y-intercept. Now we're going to write our equation of the line, and this is got another extra little interesting thing. You always put a hat on the y variable. Always, always, always. I actually take off points, so does the AP. Write y equals like you would do in math class. So you write y hat equals negative 0.013, the y-intercept, plus 0.18 times x. Again, equals mx plus b, used to this part being before the y-intercept, but we do write it in this order. And the reason why, and I would strongly recommend you take out your yellow formula sheet that I gave you last class, because I'm going to be pointing out a couple of things on here. It's because I want to match this form that's written right here, this second formula here. You see that that looks almost exactly like what the calculator says. The only difference is it's got that. So I wanted to just match our formula sheet and use the same notation. Okay. The other weird thing that we do, and you would have noticed this when you did that rat problem for the CYU, is that we oftentimes change the x and y to be variable names. You've done this for like change x to t for time or c for cost. We've done things like that but in math class. But in this class, we actually sometimes will write an entire word in. Maybe instead of y, we write BAC and then put like a giant hat over the top equals 0.013 plus 0.018 times beers. So it looks just like the last equation, the same numbers, but just put in variable names. If you really hate this, then when you write it, you're welcome to keep it as x and y. You'll just have to define off to the side what does x represent and what does y represent. So now this line is representing this like model for what's happening here. But we do understand that the line is just predictions. It's not exactly what will happen. See that if I, for example, plug in 4, I'm going to get a number kind of in between the two numbers that I have already with my dots. So we need to kind of switch our way of thinking. The line is actually wrong and the points actually happen. That's what's right. So whenever we talk about things that we do with our lines, we talk about the fact that it's a prediction or an estimation. It's not exactly what happens in our data. That's what you're going to do down here. You're going to make a couple of predictions and you're going to describe what the slope and the y-intercept mean in the context of the problem, just like you did with the rat problem. So use the homework answers as a model for that. And what I'd like is for the substitute to pause the video right now. Yep, press pause and I can a second with the answers. All right, we should have tried these 3 or 4 bullet points, and let's now my answers. So the prediction for 2.5.032, so that shouldn't have been a big deal, just plugging into the equation. This is how I wrote the sentence slope, but yours could have been different, so don't like tear yours up yet. The big thing is realizing is that the 0.018 is how much your blood alcohol content goes up for every 1 beer. So you need to realize that when you think about slope, it is a rate, so you put it over 1, and it's always your y variable over variable. So this number describes blood alcohol content, this number describes your beers. So I wrote the line predicts the blood alcohol content by 0.018 beer consumed. You could have said it in a different order, but you did need to include the context and you need to make sure you had the right variables with the right numbers. The other thing is you have to say prediction or an approximation. You can't say that blood alcohol content will increase 0.018 for every 1 beer. You have to make sure it's a prediction. Next, the y-intercept, that's the negative 0.013. What I always like to think about is that's whenever your x is 0, so you just kind of cover up your x here or in either equation, and you see, oh look, it's saying your blood alcohol content is equal to negative 0.13 when you have no beers. Now that's kind of weird. Like, how do you get a negative blood alcohol content? Sometimes this happens when we're trying to make that line go down through the middle of points here. Sometimes the way it tilts makes a y-intercept that doesn't really make sense in the context of the problem. So you still interpret it, and then you might be asked, like, is this a relevant value to the context? And you would just indicate in this case, no, we can't have negative alcohol content. Also note that I used a different disclaimer, but I definitely made it clear that it's an estimation. And then finally, just like with the rat problem, I wanted you to make a prediction, and I don't know if this is reasonable. This is pretty extreme to me to have a blood alcohol content of 0.257. The problem is that we don't know that this same line that does go on forever will actually be the way the points will continue. Maybe the points will turn up. They'll start to level off at some point. That I'm not going to be able to tell, so it would be inappropriate for me to try to make predictions with a line far outside the range of the x values that I have. Collected data from 1 beer up to 9 beers. I don't think it's appropriate to collect data on 15 beers and to assume the line's going to continue the same way. We call this extrapolation. We don't know the trend will continue to be linear. So do not do this in the future. We just need to be conscious of that. All right. I'll be right back for the back of your notes.